Okay, we're almost done, but arrays are really useful not just because they can go into one dimension, they can also have multiple dimensions. We're only going to look at two-dimensional arrays, but it's possible to have 3, 4, 5-dimensional arrays. They're harder to visualize, obviously, once we get past 3 dimensions, but let's focus just on how a two-dimensional array looks in Java. So where this might be useful, if we have multiple dimensions, you could imagine a chessboard, an 8x8 grid of squares, or Conway's Game of Life, where you need a grid of cells. One way to think of those things would be as an array of arrays. So there's a project in this chapter called Brian's Brain. I think it's Brian's Brain. And what you have is you have an array of cells, and then you have an array of the array of cells. And so you end up with rows and columns. The way you end up processing this is if you're looking for an individual cell, you need to know which array it is. So you need to know what row it's in, and then you need to know which column it's in within that row. The Brain project is actually kind of interesting. Just want to show it briefly, in that it's similar to Conway's Game of Life. But it actually has 2 states rather than just 1 state. So we have an environment class, we have an environment view class, which is responsible for taking the information about the two-dimensional array and converting it into visual data. And then we have an individual cell that makes up the core of how the environment needs to operate. So we will make a new default environment, which looks like this. And our cells from Brian's Brain, a cell can either be alive or dead or dying. And based on that, it gets a color choice. And as I recall, the color mapping is a little odd. If we look at the environment, and we're looking, oh, maybe it's the environment view. I'm sorry, environment view is responsible for this. So it's odd, but the alive cells are white, and the dying cells are the darker blue. I'm sorry, the dead cells are the darker blue, and the dying cells are that kind of yellowish color. These colors are based off of RGB values, and you've probably been exposed at least a little bit to the concept of RGB values. It gets discussed a lot more heavily inside of the course Interactive Multimedia, where we talk about the technical underpinnings of visual media inside of computer systems. Okay, so you want to pay attention to the white cells. The white cells are the ones that are alive, and you could remap those colors if you wanted to. I'm going to run this, and you can see that, almost immediately the number of white cells drops off. So similar to Game of Life, what we're seeing, I'm going to increase the animation speed here, we have patterns that start to move, we have patterns that look chaotic and then stabilize, and what we are seeing is that living cells, especially if they're moving, tend to be trailed by the dying cells, and then eventually the dying cells on the next iteration become dead cells. So this is another example of cellular automata, but in particular, the important thing for our purposes is that it is a two-dimensional array. So an array of cells that we then go ahead and manipulate on each subsequent step. So what I do want you to keep in mind whether we're dealing with that simpler linear cellular automata or we're dealing with this more complex cellular automata. This comes in on any kind of interactive simulation and will definitely be of use to those of you in the game program. We don't make changes to the current state while we're analyzing it. So when it's time to compute the next step, we figure out how many rows and columns we have. We make a completely new two-dimensional array that's the same size as the previous one. Then we need to go through and process all the information in the current state in order to be able to see where things are going. And then we need to copy that information back over so that what was previously the next state becomes the current state. So there's a little more work here because we're dealing with objects, where you're dealing with cell objects, not just a primitive in integer, but the same process is involved, where you don't make any changes to the state until you've processed all of the situation, all of the cells, all of the nodes in the current state. And the good news is the computer can do that very quickly, so that while it seems like an onerous task if we were to do it by hand, it actually can be done fast enough to go at greater than 30 frames per second and produce a smooth animation. Okay. So one way to deal with the brain project is that array of arrays. I'm sorry, the two-dimensional array value. The array of array style allows us to just ask the arrays that make up the grid for the length directly. So we don't need to know num rows and num columns. This allows for non-square array types, which is to say that each row in an array could have a different length, as opposed to having to be a predefined set grid. And that could be useful. Finally, and this is just mentioned in passing, there'll be a section at the end of Chapter 7 that ties back to Chapter 5, how arrays can be used with the stream method. You may read that if you are interested, but it is not a requirement. And just know that when you eventually start using streams, that they can be used with arrays. Okay, that wraps up Chapter 7. I hope you enjoy playing around with arrays in this week's lab, and I will see you next week for Chapter 8.